Hello there, developers, and welcome to this journey where we'll be trying to implement our own custom animation system and classes for Android in Java without using any dependencies or external libraries. And for that purpose, we have this very empty project here with one activity that is currently empty, as you can see here, a black screen, and no layout files and no drawables except for the icon. Anyhow, we can begin with the first step here, which says add rect to window. And to create a rectangle, we can use the very basic view class in Android. Let's name it rect, and it's just a new view with context, which is this. And we can give it a layout params object. I'm going to use frame layout, so I'm going to use frame layout.layout params, and the size is going to be 300 by 300 pixels. And this rectangle, we're going to make it white, set background color to color dot white, like that. And then we're going to create our frame layout, name it root, and it's a new frame layout that takes this for its context. And it does root.add_view, and it says set content view to root. If we run this, we're going to get a very simple white rectangle. At the top left corner, we want to bring it to the center. And for that purpose, we can take this params value, can save it separately into a variable, and we can set the gravity on that variable to gravity.center, and we need to import this, and then we need to set these params on the rectangle. It's going to be brought to the center of the frame view, and I also want to give it some round corners, and there isn't a very simple way to do that. We need to use a gradient drawable for the background. We can name it background. There's a new gradient drawable. And this drawable will have its corner radius set to 40 pixels and its color set to color white. So this line here, instead of setting the background color, we're going to set the background to this background drawable. Now we're going to have a simple rectangle with round corners. It does nothing. You can click it, you can talk to it, but it doesn't reply. But now we're done with this step. We can move on to the next one. It says create animation base. I prepared this package where I'm going to add the animation class. And the animation class is going to be the base class for every animation in the app. And its functionality is very simple and basic, which says it takes a value, let's name it progress, takes it from 0 to 1 and across a duration. So we need a private long duration in milliseconds. We need a let's say we need a variable for the, let's make it static, for the frames per second. Let's say long, not long, it's float. Let's say FPS equals 60 frames per second. And we can do public animation long duration. We can add another variable attribute for the interpolator. We can make our own interpolator here. Interpolators usually change the speed of the animation across its duration. You have ease in, ease out, accelerate, decelerate, overshoot, anticipate, linear. You have many types of those. You can look them up. It's a separate topic, but I'm going to use them in my package. So I need a constructor that takes an interpolator, and I need what I said, a constructor, right? And then I need a constructor that takes both, and I'm just gonna generate it because I'm a lazy developer, like this. And I'm gonna make some setters for duration and for interpolator. And setting duration, I need it to return animation, so I can chain these commands, these calls. I can make it return a generic type that extends from animation, and I can make it return this cast to the generic type, and it throws a warning, which we can reply to by suppressing it. Set interpolator can use the same logic. We can take this code, put it here, and this code, put it here. And now we have an object, a class basically, that allows us to create an animation object with a duration and an interpolator, and the FPS is fixed at 60. we need a way to start it. So we can do public void start. Starting an animation needs to keep track of when the animation has started. I think this auto-completion algorithm is onto something here. And we can elapsed time. No, we don't need it yet. We need the now, which is start time when the animation just started. And we need the last time it has updated to keep track of our frames per second, which is also start time. Although it hasn't updated yet, maybe we can make this -1 for convenience. And now we need to make a loop that says, oh my god, this is so correct. If last updated equal, no, this is wrong. Okay, let's see. If now minus start time is different than duration, the loop is gonna execute. And now is gonna become, now is gonna become this. And for the frame rate, we can do if now minus last updated greater or equals to 1000. Okay, this can work. And what are we gonna do here? We're gonna do, okay, we're gonna do updates, which we don't know what it is yet. And then we're gonna do last update is now. And like this, we can do the now up. We can also calculate something here. We want to know at any given moment, we want to know how much time has passed since the animation has started. We can say long past equals now minus start time. And then, oh my god, we can use this. Okay, the only thing wrong with this is that it needs to be float, so the result would be a fraction between 0 and 1. And we can take this and put it here so we don't have to calculate twice. We can do long progress. Oh, it's not long, it's float, sorry. And now we're gonna do our update with this progress. This progress is basically how much time has passed since the animation has started, divided by the duration of the animation. So it returns a fraction between 0 and 1, that thing we talked about, the progress that gets animated between 0 and 1. What we do with it is unknown, so we're going to make this class abstract, and we are going to make a public abstract void update. And update takes the float progress and does nothing with it. For now, we can do this and this. For now, we can say this class is... it looks done to me. We can test it. We can test it here. We can say when the rectangle is pressed, set on, click listener. We can make a lambda expression here and say animation. You can name it something more convenient to retype. We must override this because it's abstract, and we need to give it a duration. We can make a constructor that does not take a duration. It sets it to, okay, I can make use of the same constructor if I say this, and I give it a default value for the duration and the interpolator. And I can do the same with this. I can give it the duration and a default interpolator. And we can basically make a constructor that takes nothing, and it does this, about 300 milliseconds, and decelerate interpolator. This is kind of ready. I can pass nothing here. We have to go on a separate line and do starts here. And in the update, I'm going to do something very simple. I'm going to log the progress to the logcat. String volume progress. Yeah, that makes sense. That would work. And I can start this. I can pull this up here, and I can click and watch. You can see that there is a value that is going from 0 to 1. And what are we doing with it? We're only printing it for now. But this task is done. We can see about the value animation. And the purpose of this class is to reproject the range. So the range, let's say we had a progress that goes from 0 to 1. We're going to reproject it to a value that goes from a custom defined by the user, to a custom defined by the user. And for that, we're going to extend from animation. We're going to have some private float from, nice, private float to, nice. We need the constructor. We can do duration. This is not bad. This is not bad at all. We just need we need the update. Wait. If we don't give it the duration, we cannot give it the duration because we can do something like this and this. Anyhow, we need to override the update. Here, we need to do the reprojection from this value goes between 0 and 1. We need to make a new value that goes between from and to. And that is fairly simple. I think the autocomplete is going to show me how to do it. Exactly. And what we're going to do with it is also unknown at this step. So we're going to make it abstract. We're going to say public abstract. Let's say update value, which takes a float value, but it doesn't know what to do with it. And it's void, by the way. So here we can take this and pass it to update value. Brilliant. From is, it shouldn't be final because it needs to have a setter. So this way the warning is going to go away. We can remove these lines. So this class is done. We need to test it before being sure that it's done. Let's say value animation is a new value animation and it says update value and it needs to take some params. Let's make from to, let's say it goes from 100 to 300. And we'll see how that prints to the logcat. Exactly. From 100 to 300. We're not seeing 300 here. Maybe we can add something. When the while loop, when it finishes, it's gonna do update 1. Yeah, that makes sense. And now we're gonna see the 300 value there. Exactly. Yeah, nice. So this class is done. We need a view animation, which takes a value animation and applies it on a view. So we need a new class called view animation, like so, which extends from value animation. It needs to implement update value, and it needs to create constructor matching super. I'll take both of them, and I will make a protected view, and I need to wait a second. I can just import this. I need to add a parameter to the constructors here, and I can say this dot view equals view, and I can do the same here. And update is gonna apply this value on the view, but it doesn't know how yet. This is also an abstract class. Just maybe we can leave the update value undefined and call it a day. I mean, what's wrong with this? Now we are gonna move to the next step, which is creating a rotate animation. In the main activity, we can test our view animation, but we don't have anything to test. We must go forward first. Let's say rotate animation extends from view animation, and it does need some constructors, of course, and it does view dot set rotation value. Done. And in the same way, we can do translate Y animation, and it extends from view animation, no, not view animation, and it does this, and it does these, and it says view dot set translate Y value. So in the main activity, I'm done with this. I can delete this code. I can say rotate animation test equals new rotate animation. I can give it the view, which is our rectangle. I can give it a duration, but I don't want to. I can do something like this from 0 to 135 and then test.start. Is it gonna work? I don't know. Yeah, it jumped. It jumped because I'll tell you exactly why it jumped. Because our animation here runs in a loop. This loop here is running on the UI thread. If you run a loop that takes 300 milliseconds on the UI thread is going to be blocked until that loop finishes. And so we're not going to see the frames while the animation is running. Only when it is done, we're going to see the last state, it said. So this work here can be made inside a thread. This is not very optimized, but it gets the job done and demonstrates this. You can use something called the Android choreographer if you want to look that up. It's something that synchronizes your background threads or rendering or any work you want to do. You can synchronize it to the device's display, but we're not going to do that. We're just going to use a separate thread so that we can see our animation working. Exactly. Something like this. So the last thing we want to do is combining animations. Let's go back to our main activity. Let's say this is a translation animation. It goes from 0 to 300. Does it work? Right, so these two animations, they both work on their own, but we want to combine them into a single animation. Of course, we can do test 1 and test 2, and we can say this is a rotate animation that animates between 0 and 135, and we can copy this and paste it twice and start both. This would probably work, you know, but we don't want to do this. Okay, so something glitched. It's not responding to my clicks anymore. It worked once and then it stopped working. Does it have to do with the fact that I am updating the view from outside the UI thread? Like this work here is happening on the background thread, but it's updating UI, and updating UI should not happen from a background thread. I doubt it is the actual issue, but it might be the actual issue. What we can do to solve it is we can go to the view animation. We can override its update value. We can say new handler, and we can do looper.get main looper, and we can do post a runnable, and the runnable we're gonna post is the actual update we're gonna put in another abstract method. We're gonna name it apply, for instance, because it applies a progress to a view, and then we're gonna go back to the translate. This is gonna be apply, and the rotate is also gonna use apply. Is this going to solve the issue? I'm not sure, but it might. Yeah, it does. It does solve the issue. The problem was that the view animation was doing some work. It was updating the graphical user interface, but from a thread, a background thread, a different thread than the UI thread. So it was causing the UI thread to glitch into not receiving clicks and touch events. And when I posted that work back into the main looper, the UI event queue, it went back to running correctly. So now we can focus on this, combining animations. To combine animations, we're going to create a new class. We can call it parallel animation. And this parallel animation extends from animation. What I want to do with this is, if I have multiple animations that are going to run in parallel, I don't want each one of them to run on its own thread. I want them all to run on a single thread of this parallel animation. So I can make a private list of animations. Let's say children, for example. We can say this is a new array list. It doesn't bother to do this here. We can make it final. All right. We can set the duration. We can do public. Okay, wait. I can use the generate function here. Generate constructor. I can generate based on all of these except the last one. If we give it a duration, if we give it an interpolator, if we give it okay, this is not bad. I am gonna override the update, and this update, it's gonna do something with its progress. It's gonna apply it on all the other animations in the list. Let's say for each animation, we're gonna do a.update progress. We can simplify this, and we can do public. We can use the oh yeah, exactly. Thank you. Nice. Thank you very much. This was so simple. I can go to the main activity, and instead of making two separate animations, I can make a parallel animation. Let's name it test equals new parallel animation, give it a duration, and then we can do add. We can add this here, and we can do the same thing. Wait a second. Something like this should work. Why does it not work? Because parallel animation should return something that extends from parallel animation, right? And what does it add? It adds a wait, give me a second, I need to think this through. It takes an animation and it returns a cast of this. And it needs to suppress unchecked, of course. Now we can go back to our main activity and find out that it's now not making any problems. We can delete these and we can only work with test. Let's see if the animations are effectively combined. Nice. Nice. If I click twice, it's gonna blink. So I can do some optimization here. The start method, let's have a private boolean for running, and it's false in the beginning, of course. And when someone calls start, we're gonna do running equals true, and here it must remain true. And if it becomes false, we are gonna stop running the animation and not execute the last update. And this way, we can do a public void stop, which does exactly, thank you. We can go back here and say that this animation can be defined here, but before we start it, we have to stop it first. Or we can do something better. We can do if it is running, we can go back to the animation class and do is running, and we can go back to the main activity and test if it's not running is only when we start it, when it is not already running, right? Oh, so it is always running because it doesn't set it back to false when it's done. So here, when the thread is done, I can do running equals false, something like this. Nice, 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 nice. Brilliant. So this is what I wanted to do. I wanted to, I can actually, I can do something with this. I can make a private boolean reverse, right? And it's false by default, reverse. I can say that progress update 1. Let's see. I can say that if reverse, we're gonna do 1 minus progress. Otherwise, we're gonna do progress. And here we're gonna do if reverse, then we're gonna do 0. Otherwise, we're gonna do 1. So here I can do set reverse. Let's put it here, set reverse. And I can do is reverse. So in here, main activity, I can do start, but before it starts, let's say here that something like this, test dot set reverse, test dot is reverse. We can do this here, And we can make it reverse at first, so it gets reversed back to false when it begins. I want to see it come down and then go back to its original location, like this, and like that, like this, and like that. As you can see, we have created a custom animation here, which basically just animates a volue from 0 to 1, and that volue doesn't know what to do with it yet. It goes to the subclasses, starting with volue animation, which reprojects this volue that used to go from 0 to 1, now goes from a custom defined volue to another custom defined volue. But what to do with this volue is also unknown, so we need to go further in the subclasses. We need to go into view animation, which extends from volue animation, which animates basically a volue from a custom defined to a custom defined, but now it has a view. It applies this volue on a view, but how, it doesn't know yet, so we need to go further in the subclasses. Translate Y, for example, extends from view animation, and it applies that volue to the translation Y property of the view. Rotate animation does this, sets rotation. We can do something like scale XY animation. We can make it extend from view animation, and we can say implement, and we can create the constructors, and here we can do view.setScale X to volue and setScale Y to volue. And now if we go back to the main activity, we can add one more animation here. We can do scale XY that goes from 1 to, let's say, 1.5f, because it's a float. And it's going to be automatically reversed using the reverse property. Yeah. You see that? So it's basically working. It's not very optimized, but it gives you a custom idea of my own on how to create custom animations for Android apps in Java. To test this further, I'm going to try to check the build file. It says Minify. I'm going to try to build an APK for this and see the size of the file is 53 kilobytes. It's very, very small. But since we are making our own shit, we can get an APK, a functional APK, as low as 53 kilobytes. Of course, I'm going to upload this code somewhere on GitHub and post the link in the description of this video. So thank you for watching.